All right, so we're going to continue to look at the graphs of these polynomials. So this is going to be section 2.2, day 2. All right, so the directions are the same. Sketch the graph of the function by applying the leading coefficient test, finding the zeros of the polynomial, plotting sufficient solution points, and drawing a continuous curve through the points. Okay, so the first thing we're going to do is we are going to determine the end behavior by applying the leading coefficient test. So the leading coefficient test, remember, we look at the leading coefficient. Is it positive or negative? Well, x cubed that we're looking at, that's positive. And then we have to determine, is it even or odd? And it's to the third power, so that would be positive and odd. So you have to think about what is going to be the end behavior, and that is going to be your rising disco. So that's going to be falling to the left, but rising to the right. So the first thing you want to do is figure out what's the end behavior going to look like. Then we have to kind of figure out what the rest of the points look like. So that's why we, for part B, are going to find all the zeros. So we know where it crosses or touches the x-axis. So we can say, all right, let's plug in f of x equals 0. So x cubed minus 4x squared minus 4x plus 16. All right, there's 4 terms, so let's factor by grouping. So I'm going to take out an x squared from the first term, so I'd be left with x minus 4. Out of the last terms, I'm going to take out a negative 4. So I would be left with x minus 4. And then rearrange this. So I would get the GCF x minus 4. And then what's left over is x squared minus 4. All right, hopefully you're thinking that this can be factored further. So I would make that x squared minus 4 because that's a difference of squareds. We're going to make that x plus 2, x minus 2. All right, so if you look at this factored form, it's very easy to tell you the multiplicity. Here, x minus 4, there's no squared, so that means that it's just to the first power. So this is going to have an odd multiplicity. X plus 2, there's no exponent as well, so it's an invisible 1, so that has 1 multiplicity. And that means x minus 2, there's only 1 multiple, right? So the multiplicity would be 1. So since it's an odd multiplicity, it'll be crossing at every single 0. Remember, even it touches, odd crosses. So then my 3 zeros would be, so x minus 4 equals 0, x plus 2 equals 0, x minus 2 equals 0. So I would have x equals 0, x equals negative 2, and x equals 2. Okay? All right, so let's plot these points. 4, positive 4, negative 2, and positive 2. So that helps us build our graph because we know the end behavior and we know it's going to cross at these zeros. Next, we have to plot sufficient points. So sufficient points are just going to tell us how high those relative maximum and minimums would be in between the zeros. So if I look at my zeros, we would need to plug in at least 2 additional points to kind of figure out how high up in between the zeros we go. So if I'm looking in between -2 and 2, a good value to plug into our table would be 0. And if I was looking in between 2 and 4, 3 would be a logical point to plug in for x as well. All right, so let's plug this into the function. 0 is an easy one. All right, so we would say 0 cubed minus 4 times 0 squared minus 4 times 0 plus 16. Well, we know that's going to equal 16. And then 3 cubed minus 4 times 3 squared minus 4 times 3 plus 16. Take a second and think about that. All right, did you get it to equal -5? Okay, so we are going to kind of graph these points. So 0 was at 16. Okay, I'm just going to change my y's then to go up by 2's. And then we can say the same for the negative values. Oh, hold on here. -12, -14, -16, -18, and -20. Okay. So plot these points that are in between. So 0 is at 16, so I'm going to put that right there. And 3, -5. So to the right 3, and then 5 would be in between -4 and -6. Okay, now that we have the zeros and the points in between, we can connect them. You have to connect it using your end behavior. So if my end behavior is it falls to the left but rises to the right, so that means that it's going to, from -2, it's going to fall to the left. It's going to come up, hit this point. It's going to come back down, hit this 0. So since the multiplicity was 1, I'm going to cross here, get to this bottom point, and then rise to the right. So that is how we are going to graph these functions. So first, end behavior, then factor. Figure out if it is going to cross or touch by looking at the multiplicity, picking some points in between the zeros, and then just graphing. All right, look at this one. It says sketch the graph of the function x to the 4th minus 4x squared. Okay. So step 1, what is my leading coefficient test? Well, it's x to the 4th, so that's positive and even. So what's that going to look like? So that's going to be your touchdown, where it rises to the left and to the right. So now find the zeros. So plug in 0 for f of x and solve. So this is 2 terms. It looks like there's a GCF of x squared. So I would be left with x squared minus 4. And then I can factor this further. So x squared minus 4 would be x plus 2, x minus 2, since that's a difference of squareds. So if you look at x squared, how many x's are there? There's 2. So that means it has a multiplicity of 2. So it is going to touch wherever that equals 0. if you look here, there's only one x plus 2, so that has a multiplicity of 1. And this also, x minus 2, would have a multiplicity of 1. So let's solve. So I could say x squared equals 0, x plus 2 equals 0, x minus 2 equals 0. So if I took the square root here, I would get x equals 0. X plus 2 equals 0. If I solved, I would get x equals negative 2. And then x minus 2 equals 0. X would equal positive 2. So I know it's going to only touch at x equals 0 and cross at negative 2 and positive 2. Alright, let's plot these zeros. So I could plug in, so add 0 on the x-axis, negative 2, and positive 2. Alright, so now that we have the zeros, we know the end behavior, we can plot some additional points. So for part C, what are some good values to plug in between those zeros? Well, hopefully you're thinking the logical choice would be negative 1 and positive 1. So if I plug in positive 1 into my function here, so I would get 1 to the 4th minus 4 times 1 squared. So then that would equal negative 3. And let's do the same thing with negative 1. So negative 1 to the 4th minus 4 times negative 1 squared. So that would be 1 minus 4 again, so that would also equal negative 3. Alright, so let's plot this to the right one, down 3, to the left one, down 3 as well. Alright, so we know the end behavior rises to the left and to the right. So from negative 2, we know that it's going to rise to the left. Then it's going to cross at negative 2. It's going to hit this point that we had in our table. At 0, it is going to just touch and then go down to that point. And then we know it's going to cross at 2. And that it's going to rise to the right. So that is our final graph. Okay? So if I look at, there's just a couple extra problems that I want to go through with you outside of graphing. So the first one says, find a polynomial that has the given 0. There are many correct answers. Well, this isn't actually that bad. So it says my two zeros are 0 and negative 3. So this is like working backwards. So if I know it's 0 and negative 3, I know that factored form would be x times, and then if it was negative 3, it would be x plus 3, because when we would set that equal to 0, then we would get a negative 3. So this is kind of the factored form, so then I would just have to distribute, so I would get x squared plus 3x. There are many answers. This is the simplest answer, but you could definitely be more creative. If you look at example 3, this one's a little bit more complicated. So I would get for my function, if I have these 3 zeros, so I have 2 x plus square root 5, 4 plus square root 5, and then 4 minus square root 5. So that would just mean that I would have x minus 2. And then x minus 4 plus square root 5. And then x minus 4 minus square root 5. Alright, so I'm going to first distribute this negative to both of those terms. So I get x minus 2, and then we get x minus 4 minus square root 5, and x minus 4 plus square root 5. So I think it would be easiest to focus on foiling out the last two here. So we would see, okay, x times x, that would be x squared. So let's bring down this x minus 2. So that would be times x squared. X times negative 4, so that would be negative 4x. X times square root 5, so that would be plus x root 5. And then we could distribute negative 4 to each term, so negative 4 times x would be negative 4x. Negative 4 times negative 4 would be a positive 16. And then negative 4 times 5 would be minus 4 square root 5. And now we have to distribute that negative square root 5 to each term. So I can say this would be negative x square root 5 plus 4 square root 5, and then negative root 5 times positive root 5 would just be minus 5. Alright, so now we just have to figure out what are we left with on the inside here. So I'll bring down the x minus 2. I would get x squared. So here I would combine like terms to get minus 8x. If I look, I have a positive x root 5 and a negative, so those are going to cancel. If I look, I get a negative 4 root 5 and a positive, so those will cancel. And so the last term here would just be the constants. So we would say 16 minus 5, so that would give me 11. So the last thing would be to multiply that by x minus 2. So x times x squared would give me x cubed. X times negative 8. X would be negative 8x squared. X times 11 would be plus 11x. And then distribute negative 2 to each part. So negative 2 times x would be negative 2x squared. Excuse me, negative 2 times x squared is negative 2x squared. Negative 2 times negative 8 would be plus 16x. And negative 2 times 11 would be negative 22. Check and see, are there any like terms? Of course. So I'd be left with x cubed. Once I combine my like terms, I would get minus 10x squared plus 27x and then minus 22. Okay. All right, there's one last one. Find a polynomial of degree that has the given zeros. There are many correct answers again on this. So if you notice, they only gave us 3, but they said the degree needs to be 4. So that means, let's get started and say, well, if it was negative 4, that means in the factored form it would be x plus 4. Negative 1 would be x plus 1. And then 3 would be x minus 3. Well, the way we could kind of get around this, because right now if I multiplied all this together, unfortunately I just have x cubed. So the way we can do this is we can pick one of them and say, let's make it x squared. So we just kept the zeros the same, but just changed the multiplicity on the last one to be to the second power. So we can now FOIL this out. So if I FOILed out x to the fourth, or I'm sorry, x plus 4 times x plus 1, that would be x squared. 1x plus 4x, that would be 5x, and then plus 4. And then x minus 3 squared is going to be x squared minus 6x plus 9. So I can kind of FOIL x squared times x squared is x to the fourth. X squared times negative 6x is going to be negative 6x cubed. X squared times 9 is going to be 9x squared. 5 times x squared, that's going to be 5x cubed. 5x times negative 6x is going to be negative 30x squared. And then 5x times 9, that's going to be 45x. Let me move this over a little bit. And then the last term we would have to distribute is that negative 4. So, or I'm sorry, it's a positive 4. So 4 times x squared would be plus 4x squared. 4 times negative 6x would be negative 24x. And then 4 times 9, that would be plus 36. So last step is just to combine like terms. So it looks like I only have x to the fourth. And then here I have negative x cubed. And then we have 9x minus 30x squared. So 9x squared, negative 30x squared, and then 4x squared. So here I should get negative 17x squared. The x is 45 minus 24, so that'd be plus, or excuse me, yeah, plus 21x. And then the last part would be plus 36. And that would be your final answer.